Om Sri Sai Ram. Hearty welcome to Sri Sathya Sai Lok Seva Gurukulam online classes. How are you all? Happy? Okay, be happy and make others happy. Now we'll learn the lesson on last topic of similarity of triangles. So you are exposed to some new things about triangles. And let us just revise once what we have studied in the previous class. We started our discussion on similarity of triangles, similar triangles, and we differentiated between congruent and similar triangles. All congruent triangles are similar triangles, but all similar triangles need not be congruent. Is it not? So that was what we studied. Similar triangles are those which have same shape and size. And applications of similar triangles, just now you are seeing the properties made use of in Pythagoras theorem. And this Pythagoras theorem is used in many walks of life. And it started very long back also. And it was Baudhayana, Bhaskaracharya and so on, who gave proof earlier to the Pythagoras, long back, before Pythagoras. And also we have studied about Thales theorem, also called as basic proportionality theorem, and its converse. So converse means what? Whatever statement we say, for example, if you want to get a distinction in the examination, you have to work hard. That is a statement. Converse means if you work hard, you get distinction. That is a converse. Okay. So also Thales theorem, also called basic proportionality theorem, BPT, shortly called. And what does the theorem says? In a triangle, if a line is drawn parallel to one of the sides, it divides the other two sides proportionally. Suppose you have a triangle ABC, and suppose you draw a line parallel to BC called DE, then the theorem says this line, namely DE drawn parallel to BC, divides the other two sides proportionally, means AD by DB is equal to AE by EC. Are you following it? If D is drawn parallel to BC, then AD by DB is equal to AE by EC. That is what is called as Thales theorem or basic proportionality theorem. And its converse says, if a line divides the two sides and in equal ratios, then that line will be parallel to the base. It will be parallel to the third side. Okay. So that is what is called as converse of the Thales theorem. And we have seen the criteria of similarity. Two triangles are said to be similar under three conditions. A means what? Angle. Three angles of one triangle, if they are equal to the three angles of the other, then the two triangles are said to be similar. That is called angle similarity. We say triangle ABC is similar to PQR if the corresponding angles are equal. That is called AAA similarity. What does SSS says? Side. If the corresponding sides are equal, then we say the corresponding sides are proportional, then we say proportional, not equal. Then we say the two triangles are similar. So if you have a ABC triangle and PQR, it need not be same, please note. Only congruent triangles will be same. Here SSS says ratios must be equal. That is AB by AB, this side, by PQ is equal to AC by PR is equal to BC by QR. Then the two triangles are said to be similar. Okay. And lastly, SAS, two sides and one included angle. If they are equal, then we say the two triangles are similar. Okay, that is the criteria of similarity. Also, we have seen that ratio of two similar triangles is equal to ratio of the squares of their corresponding sides. Areas of two triangles. So he say two triangles ABC. So areas of two triangles ABC and say DEF, you say area of triangle ABC by area of triangle DEF is equal to area of triangle ABC by area of triangle DEF is equal to corresponding sides, squares of the corresponding sides, BC square by EF square also equal to AB square by D square also equal to AC square by DF square. Any one or all. So that is the meaning of that statement. That is also a very important theorem. Also we have studied about Baudhayana theorem or Pythagoras theorem. Who was Baudhayana? It is an ancient mathematician who was about 200 years before Pythagoras, who has found this Pythagoras theorem earlier to him. And what does the Pythagoras theorem says? It says a very, very important theorem, the world famous. Okay. So in a triangle, a right angle triangle, come on, anybody? In a right angle triangle, the square and the hypotenuse. What is the hypotenuse here? AC. Square and that. AC square. is equal to sum of the squares of the other two sides. One is AB, another is BC. So that is what is called Baudhayana theorem. That means suppose this is 3 and this is 4. What is 3 square? 9. What is 4 square? 16. So this becomes 5. So that is called as Pythagoras or Baudhayana theorem. This is hypotenuse. These are the two sides forming the right angle triangle. Just a revision we are telling. Already we have seen all these things. Okay, now we will pass on to the home assignments. The sides of a certain triangles are given below. Determine which of them is a right angled one. So what is the test for that? By Pythagoras theorem, longest side you must see, which is longest. 18 is longest. So we call it as C square is equal to A square plus B square. If they are equal, then we say it is right angled. So C square means 18 square. What is A square? 9 square. What is B square? 16 square. Is it equal? No. What is 18 square is? 324. Is not equal to 81 plus 256. So if you add these two, we get it as 337. So therefore, what is the answer you write? Therefore, this is not a right angle triangle. Not a right angle triangle because the square and the hypotenuse is not equal to sum of the squares of the other two sides. Clear? So one more question. Be thorough with that. Coming to second question. A7, B24, C25. Which is hypotenuse here? C. So you have to write by Pythagoras theorem. Pythagoras, also called as Baudhayana theorem. We Indians must be proud of our achievement in the field of maths, science, etc. So C square is equal to A square plus B square. C is how much? 25. A is 7. B is 24. Oh, what is 25 square? 625. This is 49. This is 576. So 625 is equal to 625. Therefore, this is a right angle. This represents, you can say, this represent a right angle triangle. These sides, you can say these sides represent right angle triangle. Okay. Because hypotenuse square is equal to sum of the squares of the other two sides. So that's all the homework. One more question is there. A ladder is placed against a wall. So this is the ladder. This is the wall. I think you know that ladder is kept slant. Why? If you kept straight, what happens? It will fall off. Is it not? It will fall off. If we keep it straight, it can't climb up. So to climb to the wall, a ladder is kept slanted like this, and it is given that the top reaches to a height of 4 meters. Here A, B, C. So AC is the ladder. So height of the ladder they are asking. Height of the wall. Height of the wall where the ladder reaches is how much? 4 meters. And we call it as AB. And if the foot of the ladder is 3 meters away from the wall, this is the wall, this foot is 3 meters. This is 4 meters. So, foot of the ladder, distance of foot of the ladder, from the wall is equal to 3 meters. Using these two, therefore, length of the ladder, this is what you call it as BC, length of the ladder is AC. How much? So by Pythagoras theorem, AC square is equal to AB square plus BC square by Pythagoras theorem. That is, what is AB? AB is 4. What is BC? 3. 4 square is 16 plus 9, 25. So AC becomes root of 25, that is plus or minus 5. We don't take minus here. So answer is 5 meters. 5 meters. Is it clear? This is the answer. This is the height of the wall 4 meters. This is the distance 3 meters. Ladder length they are asking. That is 5 meters. Is it okay? Noted? Okay, we will pass on to today's topic. Applications of Pythagoras theorem. Already we have started some more applications, very interesting one and very important also. So here are two poles. One pole is 6 meter high, another pole is 11 meter high. If the distance between the feet is 12 meters, so distance is 12 meters given here. Now they are asking what is the distance between the tops. This is how much they are asking. How to do it? For that, you have to draw a perpendicular here. So if this is 90, this also becomes 90. So what about AB? AB becomes, this is 6, so this also becomes 6. So 11 minus 6, how much? So height of the pole EC 6 meters and pole AD 11 meters and distance between the feet is 12 meters. If this is 12 meters, that also becomes 12 meters. And AB becomes 11 minus 6, that is 5. Okay. How do you get it? You have to draw a parallel to this. You have to draw a line, or you can draw perpendicular, but both are same. So then you get total length is 11. In that, this height you must subtract. Is it clear? Okay. Now using that two distances, you have to find out AC. So in triangle ABC, come on, angle ABC is equal to how much? 90 degrees. That's the construction we made. Okay. And then you get right angle triangle. So you have AC square is equal to AB square plus BC square. You can give other names also. There is no rules that you should take only ABC. PQR you can take, KLM you can take. So this is by Pythagoras theorem. So you have AC we don't know. AB how much? 5. What is BC? 12. 5 square is 25. 12 square is 144. So AC square becomes 169. Therefore, distance between the tops, distance between the tops of what? Poles. Tops of poles, that is AC, is equal to root of 169. How much? So AC is equal to root of 169, that is 13 meters. So this is equal to 13 meters. That is the answer. Distance between the top of the poles, that is AC here, that becomes 13 meters. Okay. So this is 13 meters we found now. Is it clear? Very interesting question. It's a very important one also. So go through this. Note down. Okay. We'll pass on to next question. In the figure, angle C is acute and AD is drawn perpendicular to BC. Show that AB square is equal to AC square plus BC square minus 2BC into DC. This is called rider. So far we are seeing numerical problems. Here there is no numericals. You have to prove by, prove by first this step by step. So solution is in triangle ABC, in triangle, if you take ABC, what is given you, right? In triangle ABC, AD is perpendicular to BC, that is given. So we are writing given. So AD is perpendicular to BC and AC angle C is acute. What do you mean acute angle? Acute angle means angle less than 90 degrees. Is it not? So angle C is acute. Now you have to find out AB square. For AB square you have to take this triangle. Is it not? In triangle ABD, angle ADB is equal to 90 degrees. That is given. Because AD is drawn perpendicular to BC. So if that is 90 degrees, then you can apply Pythagoras theorem. Come on. How do you apply? What is the hypotenuse here? AB. Square of that. AB square. Okay. hypotenuse square is equal to sum of the squares of the other two sides. Other two sides means what? AD square plus BD square by Pythagoras theorem. And for writing BD, so what BD means what? BD can be written as BC minus DC, correct? BC minus DC, you just see that square. So this is BD, so total length is BC minus DC. BC minus DC gives BD, is it not? That we have AD square plus, what is the formula? A minus B whole square. Yesterday in algebra, right? Come on, anybody? Formula is A minus B whole square is equal to A squared minus 2AB plus B square. Remember? The formula, very important formulas in algebra. That you apply here. BC square minus 2BC into DC plus DC square. Okay, or let me write here clearly. So I'll just take it this side, AD square plus A minus B whole square formula. That formula using here. A means what? BC here. Square of that. Minus 2AB, 2 into BC into DC plus B square. B square is DC square. Okay? By using this formula. Now, if you see the figure, AD square plus DC square means what? AC square, right? So you got the answer. Instead of AD and DC, you write it as AC square plus BC square minus 2BC into DC. So beautiful answer you get. AB square is equal to, that is the answer. But you must give reason how it came. How this AC came? Because in triangle ADC, it's right angled, is it not? Angle ADC is 90 and hypotenuse, what is that hypotenuse? AC square is equal to AD square plus DC square. That you have taken here. AD square plus DC square. That you have taken here. Instead of AD square plus DC square, you write AC square plus BC square minus 2BC into DC. That's all. Similarly, there is one more question about obtuse angle. Then you get plus here. Instead of minus, it becomes plus. It's called a rider based on the theorem. Okay. Shall we go to next sum? Okay. Next problem. ABC is a right angle triangle with right angle at C. So this is right angle. If CD is the length of the perpendicular from C on AB, if CD is the length of perpendicular on AB, and if and that is P. This is P. Then BC is equal to A. BC is equal to A. And AC is equal to B. AB is equal to C. From the figure, show that PC is equal to AB. Now we already proved it, that triangle ABC and ACD are similar. So if they are similar, you can write the ratio C by B is equal to A by P. So this is C by B is equal to A by P, which means that if you cross multiply, CP is equal to AB. Is it not? You can get this result another way also. Suppose you take area, that also gives the answer. Area, if you take area of triangle ABC is equal to half base into height. What is the base here? Suppose you take this as base, half into P into C. Height is P, base is C, half PC. This is also equal to, suppose you take this right angle triangle, that area becomes, this becomes the height, this becomes the base, half of AB. So compare these two. So half of AB is equal to half of PC. Cancel this half and half. You get AB is equal to PC. That's also okay. Or by similar triangle also you can prove any one of them. Now second one is 1 by P square is equal to 1 by A square plus 1 by B square. You have to prove. Okay. So what you have proved now is A into B is equal to P into C. Use this in this. And let us see that it taken down. Okay. Very good. We will pass on to next one, second part. So 1 by P square is equal to 1 by A square by 1 by B square. That is, we have to prove. For that, we know that AB is equal to PC. Just now we have proved it. So already proved in the first result. This is also a rider. This is not, no, usually there will be values given. Here values are not given. You have to prove by principles. So in the rights, we know that AB is equal to PC. Therefore, P becomes AB by C here. P will come down. If you square this, so how do you get it? Squaring. P squared is equal to A squared B squared by C square. And taking reciprocal. So taking reciprocal of it, we have 1 by P square is equal to 1 by A squared B squared by C square. Then C square go up. C squared by A squared B square. This is left hand side. So this is the answer you must get in the right side now. On the right side you have 1 by A square plus 1 by B square. Take LCM. A squared B squared is LCM. Then you get A squared plus B squared by A squared B squared. And in this right angle triangle ABC, this is right angle here. So this becomes hypotenuse. So A squared plus B squared is equal to A squared plus B squared is equal to C square. So here you get instead of A squared plus B squared, you write C square. And this is A squared B squared. And the same thing you get here also. C squared by A squared B squared. So both the left hand side and right hand side are equal. So left hand side is c squared by a squared b squared, right hand side is c squared by a squared. Hence the result. What is the result? Therefore 1 by p square is equal to 1 by a square plus 1 by b square. You can prove it by other methods also. There is no rigid rules that you should do in this way only. Anyway, you must get this answer correctly by principles. Okay, noted. Shall we move to next sum? There is one more problem in this. PQR is an isosceles triangle, right angle triangle. Means two sides are equal. Isosceles means two sides are equal. Q is equal to 90 degrees. Prove that PR square is equal to 2PQ square. How to prove that? So, in a right angle triangle, as usual, right angle triangle name PQR. Is it not? You are given with angle Q is equal to 90 degrees. So what is hypotenuse? Hypotenuse becomes PR, is it not? So by Pythagoras theorem, come on, one of you tell the Pythagoras theorem. Yes, square on the hypotenuse is equal to sum of the squares of the other two sides. PQ square plus QR square. PQ square plus QR square. Now you are given that it is isosceles, means two sides are equal. So you can write it up, but PQ is equal to QR. That is given, is a isosceles triangle. So if you apply it here, PR square is equal to PQ square. Instead of QR, you can write PQ, correct? Because both are equal. So you get a beautiful answer. 2 times PQ square. This is to be proved. So simple. Provided you know the theorem correctly. So you must give reason also here. By Pythagoras theorem. Okay, shall we go to next sum? Yes, last an interesting sum is there, one more. Ramu goes 80 meters due east, then 150 meters due north. Let us suppose Ramu is here now. For that you must know directions. There are 4 directions. Come on, you stand up. Show the 4 directions. Some of you know it. Where the sun rises is the east direction. Opposite to sun rising is called west direction. Is it not? So facing sun, left side is north. Facing sun, right side is south. Facing sun, behind here, west. So in the map, we show like this. In the map, you have north above and south below. This is west, that is east. Now here is a question. Ramu goes due east 80 meters. So he goes to east direction. So let us suppose Ramu is here. Goes here. How much? 80 meters. We take roughly something like some scale you have to take. We will call it as a P here, Q here. East direction means to right. From there he goes to north 150 meters. So this is 150, roughly I am telling. So this is the third point reaches. how far is he from the starting point? So this is the starting point. This they are asking. So you draw a correct figure. Okay. So here he starts from here, goes to east 80 meters. From there he goes to north 150 meters. And now how much distance he is from the starting point? So you will write it as in triangle PQR, angle PQR is equal to 90 degrees. As you know, the angle made here will be 90 degrees. And therefore you can apply Pythagoras theorem. PR square is equal to PQ square plus QR square. That is by Pythagoras theorem. So, what is PR? Don't know. What is PQ? 80. What is QR? 150. So, 80 square is how much? 8 8 za 64. 15 15 za 225. Followed by 2 zeros. Add it. You get 2 zeros. 5 plus 4 is 9. 2 plus 6 is 8. 28900. So PR is equal to is so much. PR is equal to root of this 28900, that is 170. Root of this is 17 and double zero. Root will be 10. So you have to write the answer. So Ramu is 170 meters away from the starting point. Starting point. This is the answer you must write. Ramu is 170 meters away from the starting point. So this is the starting point. This is the end point. Okay. Okay. Now we will pass on to what Baba says. 3 C's of Baba. A, B, C. C. Constructive thoughts. He always thinks of constructive things like free drinking water, free education, free medical facilities, like that, for the poor and downtrodden. Consoling words. He consoled millions of people, not one or two. Some directly, some in dreams, and some through the words of the books. And in compassionate deeds. His actions also very, very compassionate, of creating vibhuti and giving to the patients, patting in back, and so on. So that is what you have to learn from him, and you have to practice it also. Will you come prepared? Thank you.